All right, guys, so into calculus, straight into it. You can see where all of these questions are from in terms of papers. This is from September 2022. I've said to you guys already that it is a good idea to look at past mock papers. Obviously, this is what you're writing now, and so it's a good idea for you to sort of see the standard that has been set for mock papers. But yeah, right, so let's have a look. So determine the first derivative of f of x from first principles if f of x equals x minus 3x squared. Okay, now first thing, guys, we only ever use first principles or the method of first principles if we are asked for first principles, right? There is absolutely no reason why we would ever use first principles unless we're asked for it. So here we are asked to use first principles, so we do have to use it, and we're given our expression for f of x. Remember, first principles is, and this formula is on your formula sheet, so don't stress if you don't remember this formula. But first principles is you using the derivative formula, which is that the derivative of f of x is equal to the limit of h's to 0 of f of x plus h minus f of x all over h. Right, so this is first principles. You have to use this formula when answering this question. And we obviously know all the shortcut rules, so we actually already know what this first derivative is, and we'll chat about that in a second. If you're told to do it using first principles, you need to do so. Okay, so what I like to say, guys, is because we do actually know how to get our first derivative using the shortcut, I always say I'm going to find my first derivative with a shortcut. I would write it in pencil somewhere rough. It's not actually your answer. But we know that the derivative of this would be 1 minus 6x, or negative 6x plus 1. Oops. Right, that's just using my shortcut rules for the derivative. So taking the exponent of my variable, timesing it by the coefficient, then subtracting 1 from the exponent. And the reason I like to do this is so that when I do finish my first principles, I can just go back and double check that I have actually done it correctly. Okay, there's a shortcut method for a reason. Use it to check yourself. All right, so guys, when we spoke about this, I did say you can choose to do this in a bunch of different ways. However, the first thing that we need to do, and you'll see again as you go through memos, some of them present the answers a little bit differently, but at the end of the day, you need to be able to do all of the things I'm about to do. So the first thing that we do is we determine our f of x plus h. Now remember, this bracket represents your x variable. So essentially everywhere in our original expression where we see an x, we now need to replace that with x plus h. So we've got x plus h minus 3 times x plus h squared. And we determine this expression. So this is just x plus h minus 3, binomial times a binomial, x squared plus 2xh plus h squared. Distribute in that negative 3, x plus h minus 3x squared minus 6xh minus 3h squared. So that's the first thing we want to determine. Once we have that, we can now substitute in our formula. Some people like to substitute straight into their formula and simplify from there. Obviously, that's absolutely fine. There's nothing wrong with that. I just prefer to rather substitute first, simplify, and then go and sub in. All right, now, remember, guys, it is so important that you get the notation of this derivative first principles formula correct. What I mean by that is, you need to say you're working with a derivative. You need to have that the limit of h is to 0. If you forget any of this stuff, you will lose a mark. Okay, it might seem harsh, but this is where notation is important. So we substitute in our f of x plus h, which is this expression that we've just gone and found, this whole long thing. Minus f of x. So remember, f of x was our original expression, x minus 3x squared. Remember to put it into brackets because we are going to want to distribute that negative into the bracket. And remember, the goal is that, or what should end up happening is that the two terms of f of x should cancel with terms of f of x plus h. All over h equals your lim h to 0. In terms of the notation, you don't have to keep writing the derivative, but you do need to have this lim h's to 0. And now we would go and distribute. Now, obviously, grade 12s, if you can see the distribution and you can see the terms that are going to cancel, you can just go straight to the simplified version. I'm just going to do the distribution so we can see. So this would be minus x plus 3x squared all over h again. Oops. And now we essentially gather our like terms. So x minus x, they cancel each other out, and negative 3x squared plus 3x squared cancel each other out. Now that should always happen. You should always cancel out your f of x terms. If you don't, you've done something wrong. Right, so once again, our limit where h is to 0 is equal to, now in my numerator, I just have h minus 6xh minus 3h squared all over h. And this is now where our third step comes in. We need to go ahead and factorize. Okay, now the factorization will always involve you taking out a common factor of h. Even if there is more common, you only need to take out a common factor of h. And the reason is because you want to cancel out your denominator. You want to simplify this fraction and essentially divide away the h in the denominator. So this will leave me with 1 minus 6x minus 3h all over h. And again, the goal of the factorization step is to be able to get rid of those h's. And so now what you have is 1 minus 6x minus 3h. And your fourth and final step is to actually get your derivative. So what I mean by that is substitute in 0 in place of h. So everywhere you see an h, you now replace it with 0. And you get that your first derivative is equal to 1 minus 6x. Because here, negative 3 times 0 is 0. That falls away. And so here is our derivative. Now remember, right at the start, we just use our quick little trick or our quick little rule in order to get our derivative. And because this now matches up exactly with the answer that I got, I use it as my check. I can see that I got what I initially anticipated I was going to get for my first derivative. And so I have done my first principles correctly. So it's just a nice little check for you to be able to do so that you can make sure you are doing it correctly. Sorry guys, technology today. Right, now you will always get a first principles question. It's guaranteed. Just accept it. It's going to happen. These first principle questions are generally worth 5 marks. Sometimes 6, but 95% of the time it's a 5-mark question. And if you think of that in terms of the fact that calculus counts about 35 marks, what that means is a 7th of those marks is already just first principle. All right. Sorry, I need to change my headphones. All right, can we all hear me? Just give me a thumbs up if you can still hear me. Great, thank you. Okay, so first principles, nothing stressful. However, you are going to be asked a question. Don't lose 5 marks because you've forgotten how to do your first principles. Okay, it's 4 easy steps. Find f of x plus h, sub it into your formula, which is on your formula sheet. Simplify and factorize. Get your first derivative. That's it. Right, so I'll just wait here in case anyone wants to take a screenshot, and then we'll have a look at the next type of question that you will get in your calculus section, which is determining the derivative using the shortcut rules, but making sure that your formatting is correct, your notation is correct, etc., etc. All right. Okay, so this is going to be your first question in calculus. Calculus is usually a question 9, I think. Oh, I'm guessing. Yeah, I should know, but I can't remember now. So it'll be first principles and then it'll be notation. Generally, you get like 2 or 3 notation questions. And like I say, this is testing whether or not you understand what format your expression should be in before you find the derivative, as well as do you actually understand the notation. So we did go through all of this in our lessons. However, obviously, again, we're going to chat about it. You do not use first principles here, grade 12s. Okay, first principles here, because generally these expressions are ugly, is going to be a nightmare to try and use. So we just go straight to the rules. So remember, the rule is if you have been given ax to the power of some exponent, your derivative will require you to multiply your coefficient by your exponent, so n times a, and subtract 1 from your exponent. That is how we find the derivative with our shortcut rules. And remember that the derivative of a constant is 0. Okay, so those are the two main ones that we need to know. We then also need to understand the formatting of our expressions. So if we look at question A here, the issue I have immediately with this question is the fact that in my second term, my denominator contains a variable. So this is what I have an issue with. We never want a variable in the denominator. So can someone tell me how I would get that x squared out of the denominator? How could I now write this expression? So how do we get that variable out the denominator? Kanye?
Ma'am, the way that I did it, I said -4/1, and then you take the x like above, and then you make it x to the power of -2. And
Perfect.
then you change it to -4x to the power of -2.
Perfect, exactly. Okay, guys, so that is exactly it. We need to use our negative exponent laws. We know that if we've got an x in the denominator, we can move it up into the numerator, but that essentially means it becomes a -2. And I like what Kani's saying there. It would be 4/1 times the x to the -2. We can just write it as -4x to the power -2. But just bear in mind that when you move your base and its exponent, the coefficient would stay there. So if, for example, this had been 4/3x squared, the only issue I would have there is the x squared. I've got no issue with the 3. So it would be 4/3, but now I'm bringing the x squared up to be -2. So always just be very, very careful when you are moving exponents and you are creating negative exponents that you're only moving what is applicable. All right, now that we've got our formatting correct, this is now where we find the derivative. Now, guys, with this d of x notation and the square brackets, we keep that notation there while we're still sort of fixing our expression. But the second we start with the derivative, we drop it. So because I'm now going to start doing the derivative, I'm just going to drop that d of x. I don't need it anymore because this is now the derivative. So using my rule, I know that I need to go and take the exponent, and remember we go term by term, so this is my first term. Take my exponent 4, times it by 3, and then subtract 1 from that exponent. So this is going to be 12x to the power 3, and then I move on to my second term and I do exactly the same thing. Now remember it's a negative, so just be careful. When you multiply the -2 by -4, you're going to get a +8, and then we'll obviously subtract 1 from the exponent. So you will end up with +8x to the power -3. Now, guys, you can leave your answer like this. There's no need to write your answer with positive exponents. We do know, however, that we should always write our answer with positive exponents. However, in calculus, that's not what I'm testing. What I'm testing is that you can apply the rules, that you do simplify your expression appropriately, etc. If you were going to write this with the positive exponent, it would be 12x cubed plus 8/x cubed. Both of those answers are perfectly fine. We will accept both of them. So if you do write it with a positive exponent, that is absolutely fine. There's nothing wrong with that. Obviously, it's correct. But just note that it's not necessary. Okay, so you can, but it's not necessary. All right, so this is just testing your notation, testing your ability to be able to derive and do what you need to do. All right, I'm just going to move this a bit up because really. All right, question B, similar sort of thing. We're testing your notation. So this dy over dx is saying the derivative of the expression y in terms of the variable x. So here's my expression y, and here's my variable x. Any other variable that then exists, we treat as a constant. So even though we've got an ax squared here, we're going to treat that as a constant, as if it was just a coefficient of like 5 or -3 or whatever. That a does not need to be derived using our exponent rules that we were given. Okay, if this had been the derivative y over d of a, then we need to derive in terms of a. But it's not, it's asking me to derive in terms of x. All right, so again, what we need to just sort out is our formatting. Can anyone tell me which part of this expression I have an issue with? What do I need to fix before I find the derivative? Very nice, well done. Okay, so I've got an issue with my surd here. So I need to sort out that surd, and this is now where your rational exponent laws come in. Just as a reminder of that, if you have got the nth root of a to the power m, to write that as a rational exponent, it would be your base a to the power of the exponent a was originally raised to divided by the root. I always think of roots at the bottom of a plant. So the denominator of this fraction must be the root. Probably really silly, but that's just how I remember it. Okay, so can anyone tell me how I would write the square root of x? How would I convert that surd to a rational exponent? Nice, Lorato. 6x to the power a half. That is my rational exponent. I've sorted out my formatting. Again, do you see how I'm not using derivative notation? I'm still just working with y because I have yet to actually find my derivative. I'm still just sorting out my expression. But now I am going to find my derivative. So now I do need to have my derivative notation. And again, grade 12s, you will lose a mark if your notation is incorrect here. We're now starting with our derivative. Okay, so now this is where we just need to be careful because we have that a value, and that could maybe trip us up. X is what I'm finding the derivative in terms of. So in this first term, I'm going to treat this as a coefficient and just x. X has an exponent of 1, so I'm going to take 1 and times it by my coefficient. So 1 times a squared is still just a squared. And then I'm going to subtract 1 from my exponent. And so I end up with x to the power 0, which we know is just 1. We then move on to our second term, and we do exactly the same thing. My variable that I'm trying to derive in terms of is x. So I'm going to take its exponent, times it by the coefficient. A half times 6 is 3, so plus 3. And then I'm going to subtract 1 from my exponent. A half minus 1 is negative a half. So 3x to the power negative a half. And that's it. Obviously, we'll fix that now. If you wanted to, once again, take that that rational exponent and put it into a surd, you could. Generally, we prefer rational exponents rather than surds, but you could convert it if you really felt that way. But I would just leave this as a squared plus 3x to the power negative a half. And you have found the derivative of y. All right, so guys, these questions are testing whether or not you understand your rules, you understand your formatting, etc., etc. Like I said, generally there's only like 2 of them, 3 of them maybe, but all it's testing is that you understand your rules, which is why I'm telling you that you don't have to use you don't have to convert the negative exponent to a positive or the rational exponent to a surd. That's not what we're testing. We're testing your calculus or differentiation rules. Lorato?
Hi, ma'am.
Hi.
Ma'am, do you mind re-explaining the first step? I mean, I think it's the second step where you solved for the a squared and then made the bracket of x because you were kind of cutting on my side.
Oh, sorry. Okay, so if we just go over that term again, and what I'm actually going to do is I'm just going to put the term here. So the first term is a squared x. If I want to find the derivative of this term and I'm deriving in terms of x is my variable that I'm going to apply this rule to. So x is an exponent of 1. My rule says take that exponent, multiply it by the coefficient. Now my coefficient is a squared. So 1 times a squared is just a squared. My rule then also says subtract 1 from the exponent. So you end up with x to the power of 0, which is 1. And a squared times 1 is just a squared. So that's why, whoops, my derivative here of that first term is just a squared. And the x essentially falls away because of our rule, and we just have essentially what is a constant. Does that make a bit more sense? Okay, cool. Right, so guys, don't get like confused. Don't get yourselves tripped up if all of a sudden there's another variable. You derive in terms of whatever variable you're told to derive in, and everything else you just treat as a normal number, as a constant. Okay, don't try and overcomplicate your situation. Alrighty, I'm going to let you screenshot. I don't know what I'm trying to do here. Sorry. No, okay. Barato?
Ma'am, do you mind also showing us if they had asked us to derive for A?
Okay, so if they'd asked you to derive for A, essentially what would happen is this whole term at the end would fall away because that would be considered a constant. So you'd actually only be focusing on this term here. And what I would actually do is I would swap it. Because x would now be your constant, I would write it as xa squared. You would then times your coefficient by 2, so 2x, and you'd subtract 1, so 2xa. That would be your derivative. And like I say, your last term, because of the fact that there's no a in it, it's essentially a constant. And so we know constant derivatives just fall away. Okay. Alrighty. So let's have a look at your next question. So those are the first two questions you're going to get. And then we get into our cubic functions, cubic expressions, and working with those. Right, so we have been given f of x is equal to x cubed minus 3x plus 2. And the first question asks us, determine the coordinates of the turning points of f. Does anyone remember how to find the turning points of a cubic function? What do we do? Good, Kani. And first derivative, what do I do with the first derivative? Nokubonga, what do I do?
Ma'am, I wanted to say that our condition for the turning point is f dash of x is equal to 0.
Perfect. Okay, so guys, that's really, really important. When we're looking for our turning points, this is where our first derivative, or f prime x, is equal to 0. That equal to 0 is super, super important. If we forget that, then we're going to be getting some strange things. Now, again, grade 12s, when you're finding the first derivative, yeah, sure, if you really felt that way, you could use first principles. But why? Okay, there's no reason to use first principles if it's not necessary. So this is our important sort of takeaway. We want to make the first derivative equal to 0. And so obviously what that means is I actually need to find the first derivative. So I'm going to give you a minute. Find the first derivative for me of f of x. You've been given f of x at the top. I want the first derivative. I'll give you a minute. Nokubonga?
Do you need me to tell you the thing, the first
Yeah,
derivative?
I'm ready.
3x squared minus 3. That's our first derivative.
Perfect. 3x squared minus 3. So the constant 2 falls away. Constants derived to 0. And we apply the rules thereafter. I don't think I need to go through the rules again. Then, as Nokubonga said earlier, we have to now take this and make this expression for our first derivative equal to 0. And we want to solve for x. So again, I'm going to give you a minute. I want you to solve for x quickly for me. Remember, guys, a cubic function generally has got 2 turning points. And so we just need to be mindful of the fact that because this is a quadratic, we should be getting 2 values for x. If you want to go a step further, it does say calculate the coordinates, not just the x coordinate. So you can go ahead and find the y, but I'm just asking for the x for now. Right, can anyone tell me what the 2 x coordinates of your turning points are? Nice, Layla. Okay, 1 and -1. Guys, you've got options here. Personally, I wouldn't even do what I'm about to do. Because I can see I've got a highest common factor of 3, I would just divide everything by 3. So that would leave me with x squared minus 1, and obviously 0 divided by 3 is still 0. You then have the difference of squares, x minus 1, x plus 1, giving you 0. And so, yes, x equals 1 or x equals -1. Just a quick little tangential sort of comment here, grade 12s. A lot of you like to do, no, I don't know why I went from there. Sorry, I want to go one up. A lot of you from this point like to then say x squared equals 1 and then square root both sides. I have got absolutely no problem with that. But please remember, when you square root a value, you need to have that plus or minus. And so your answer here is plus or minus 1, which tracks. Look at our 2 solutions, +1 and -1. So there's nothing wrong with doing the square root, but please remember the plus or minus. Not like so many of you do this perfectly, but you forget the plus or minus. And so you end up leaving off an entire solution. So again, no issues, but please remember to actually go and add in your plus or minus. Right, I now need to get the y coordinates. I've got the x, I now need the y. Remember, to find y, you need to substitute back into your original f of x expression. So the x cubed minus 3x plus 2. So we need to work out what f of 1 is and what f of -1 is. Now, grade 12, this is just a substitution, so I don't actually need to see you substituting in. I'm going to show it to you just so that you can see. But I don't need to see this. You can go straight to your answer. There's nothing wrong with that. So where f is equal to +1, y is equal to... y is equal to 0. Where f is equal to -1, again, you substitute in. Just be careful, -1 cubed is -1. So where f is equal to -1, y is equal to -2. -2? -1 minus 4 plus 2. Yes, I can do math. Does everyone agree with me? I'm panicking and I probably shouldn't be. Oh, because no, I'm not right. Sorry. It's a -1. It would help if I substituted it correctly. -1 plus. So -1, -3 times positive. -3 times -1 is +3. So -1 plus 3 is 2. 2 plus 2 is 4. I do apologize. So our 2 turning points are at 1, 0 and -1, +4. Kelebogile?
Ma'am, how did you get the x squared minus 1 equals to 0?
Okay, so I saw that in my expression over here, I've got a common factor of 3. So either you can take out the common factor of 3, or you just divide each term by 3. So 3x squared divided by 3 gives me x squared. -3 divided by 3 gives me -1. 0 divided by 3 is still 0. And so I just essentially started factorizing my expression.
Okay, ma'am. Thank you.
Okay, good. Can anyone tell me what it means when we have a turning point that has a y coordinate of 0? So here this turning point is at 1, 0. What does that mean about my graph? Nice, guys. I'm seeing your answers come through. I'm not ignoring you. Just giving everyone a chance to think. Okay, good. So Remember, when y is equal to 0, what you have is an x-intercept. And we did speak about this, but remember, because your turning point is also an x-intercept, you need to bear that in mind if you were to draw your graph. So not only is this a turning point, it is also an x-intercept for your cubic function. So if I start to imagine my cubic function, we know we've got a turning point at -1, 4, so let's just pretend it's there. And we have a turning point at 1, 0. You're going to have something that looks like that, where you've got a turning point and an x-intercept. So just bear that in mind, something to bear in mind. I can guarantee you we're probably going to have to sketch this graph at some point, and so starting to think about the shape is really important. Right, question B says, calculate the x-intercepts of f. What do we do when we want to calculate an x-intercept? Who remembers? Yep. Okay, synthetic division, factorization of your cubic, however you want to do it. Remember I said to you, I don't really mind. But yes, importantly, we want to make y equal to 0. So anytime you're looking for an x-intercept, this is now where we say y equals 0. Right, great tells again. I don't particularly mind how you choose to do this. I am not comfortable, not confident with synthetic division. It's just not something that for whatever reason makes sense in my brain. And so it is absolutely fine if you do it, but it's not something that I enjoy doing just because I know I'm not confident at it. I'm fully aware of the fact that that is something I must just go watch YouTube videos on and be confident with, and I will do that in my time. But for me, I prefer to factorize. If you prefer synthetic division, it's absolutely fine. There's nothing wrong with that. Okay. So I'm going to give you 2 minutes to calculate the x-intercepts. When I do it, I am going to factorize, but if you've done synthetic division, you should still be getting exactly the same answers. So it's fine. All right, 2 minutes. Let's find our x-intercepts, and then we'll go from there. If you want to know, the next question is going to be, no, it's not apparently going to be anything. I think I've lost my mind. No, sorry, please ignore it. Just ignore me. Okay, can anyone tell me what their x-intercepts were? So what were your final answers here? We obviously already know that 1, 0 is an x-intercept, but where else do we have an x-intercept? Anyone? Nice, Nokubonga, -2. If anyone did do synthetic division and feels comfortable putting it on their camera and showing us what they did and explaining it, I would appreciate that. I will be honest. If you don't, that's absolutely fine. Like no pressure whatsoever. But if you do feel comfortable, please pop up a hand or something, because that would be nice to see. Because like I said, I know I'm not comfortable enough to do it properly. Right, just for the factorization, Kani, thank you. I'm just going to do the factorization, then I would appreciate that. I'll come to you now. So x minus 1 we already know is a solution because we know it's an x-intercept. And so all we need to do now is get our trinomial. So x times what gives me x cubed? X times x squared. Negative 1 times what gives me positive 2? Well, times negative 2. And then we don't have any x squared terms, which is a bit iffy. But if we said x times negative 2, this would give me negative 2x. And I want negative 3x. So that means negative 1 times whatever this middle term is going to be must give me a negative x, which means that this middle term must be positive x. And so now I've got a quadratic that I can go and factorize further, giving me x minus 1. And guys, because we know that the x-intercept is also a turning point, it means that I should have 2 brackets of x minus 1. So if that helps in terms of your factorization, just remember that. But otherwise, you get the factorized product of x minus 1, x plus 2 equals 0. So that means our x-intercepts are at 1 or negative 2. You can write down the coordinates if you want. Technically, an intercept is a coordinate, so we should write it down as such, but there are x-intercepts. All right, Kani, that would be amazing. I'm hoping we're going to get this right because I was losing it earlier. So if you don't mind, very much appreciated. And if you could explain it, that would also be great. Okay. Let me just, okay, there we go. I think you put your camera off. Kani, you still there? Oh, there we go. There we go.
So
Cool.
you're gonna have your equation, and then you're gonna look like for what x value makes y 0. So we found out that it was 1. And then you're gonna draw up this table thing, and then you're gonna put that value there, and it's gonna be 1. And then you put a multiplication sign there, and then you put like a star. This is how my teacher showed us. And then you see, okay, the value for x to the power of 3 is 1, and then you put it there. And then the value for this one, it's negative. They would normally be x to the power of 2, but since you don't have that, you're gonna put a 0 there. So you must always make sure, because then if you don't do that, like it can mix everything up. So we put a 0 because we don't have x to the power of 2.
Okay.
And then we have negative 3 for this x. Then you put that there. And then this column must always be your constant. So since 2 is our constant, we put it there.
Okay.
So then after you've drawn everything up, you drop the 1. And then you say 1 times 1, because there's your times sign.
Okay.
So you say 1 times 1, and that's 1 there. Then you put it on top. Then you say 1 plus 0, and then it's 1. Then you say 1 times 1, then it gets 1 again. Then you say 1 plus negative 3, and that gives you negative 2. So then you say 1 times negative 2 is negative 2. And this must always be 0. So the value at the bottom here, it must always be 0.
When you add,
Yes. So if it's not 0, like you probably did something wrong. So that's how you can check in a way. And then once you're done with everything, you make your brackets and you say x, and you take this and you basically switch the sign. To the 1. So it's going to be x minus 1. And then this is going to be x to the power of 2. It's going to be 1 x to the power of 2.
Yeah.
And then plus this 1, so this x, and then that's minus 2, so the constant.
Okay.
Yeah.
No, that makes sense. I know exactly what I've been doing wrong this entire time with synthetic division. So thank you for explaining it. I keep forgetting about, like you say, if you don't have the x squared term or the x term, you have to put that 0 there. That's what I've been doing wrong. So thank you.
Mistake now, so you just make sure.
Okay, so if it's missing, you put a 0.
Yes.
Lovely. Thank you so much. I have learned something tonight. I really appreciate you. Amazing. I hope we all got that. Thank you. Very much appreciated. All right, guys. So there we go. Even in my old age, I learned stuff. So yes, very much agreed. Thank you, Kani. Amazing explanation as well. If you want to use synthetic division, guys, go for it. Absolutely nothing wrong. I'm definitely going to be trying to use it more and more because it's always nice to have another method. But thank you. I really do appreciate it. Right. So either one, synthetic division, factorization, You do you. I know what I'm comfortable with, but I am going to practice the other one more. So we can become masters at maths. Alrighty, so we've got our x-intercepts. Kanye's beautifully explained our synthetic division. I kind of explained factorization. Wasn't as amazing, but we're there. All right, so question C says determine the values of x for which f is decreasing and will be concave down. But let's just see what's happening. So guys, first question to you, is this a positive cubic or a negative cubic function? If you look at your equation, I've just put it over there for f of x. Is it positive or is it negative? Lovely. Right, so it's positive, which means it increases, decreases, increases. Now, the next question later is going to ask us to draw this graph. So that's fine. We can chat about it. But it's just helpful to understand your shape, because when it now asks a question such as, where is our graph decreasing? What we need to remember is that for a positive cubic function, it only decreases between the two turning points. So this little middle section here that I've highlighted in yellow, that's the only section that is decreasing for our cubic function. And so what that means is, because we now know where our turning points are, remember our one turning point was at -1, 4, and the other at 1, 1. We now know the exact x values for which my graph is decreasing between -1 and 1. Importantly, we don't include those values because remember, at that value, it's a turning point. So technically your gradient is 0. So it wouldn't be decreasing. It would be equal to 0. So we don't include them. But just having the shape of your graph in your mind, super, super helpful. Okay, we'll be concaved down. So obviously we need to know what concavity is. If we just draw our graph again, sure, that's an ugly looking cubic. But anyway, so we're going to pretend it's fine. Concave down is the part of your graph that looks like a sad parabola. So this is concave down. Concave up is the part of your cubic that looks like a happy parabola. So this would be concave up. Concavity changes at a specific point. Does anyone remember what the point is called where concavity changes? Nokubonga, what's it called?
It's called the point of inflection.
Lovely. Okay, it is our point of inflection, and I see it coming through on the chat. Well done, guys. Inflection. Right, I get lazy, guys, so I eventually just call it POI, but point of inflection. Perfect. Okay, now, obviously for us to be able to write this inequality for where it'll be concave down, which would basically be from your point of inflection towards negative infinity, we actually need to know where our point of inflection is. Now, you have got two options for how you want to do this. Option number one is you can find the second derivative and you make it equal to 0. So point of inflection is where your second derivative is equal to 0. Or the point of inflection sits directly in between your two turning points. So because we know the one turning point is at -1 in terms of x and the other is at +1 in terms of x, the value directly in the middle of those two is our point of inflection. So that's probably the easiest way to go. So directly in the middle of -1 and 1 is 0. However, if you wanted to do the second derivative, we already know the first derivative is equal to 3x minus 3, which means my second derivative is equal to, would also help if I wrote it down correctly here, 3x squared minus 3, which means our second derivative is 6x. If you now make 6x equal to 0, x is equal to 0. So either way, you get the answer. Second derivative or midpoint of your two turning points, whatever. Absolutely, completely up to you how you want to do it. But now that we know that it's going to be from 0 all the way down to negative infinity, we can now say that it will be concave down where x is less than 0. Whoops, x less than equal to. Because remember, at that point, that is the point where it's concave down and then is about to change to concave up. All right, so point of inflection, super important in terms of concavity. When I put my summary notes up, I talk about concavity, and there's a little summary of concavity there for you. Right, I'm going to be honest, I have absolutely no idea what you've screenshotted. I don't think it's anything of this question yet, so I'm just going to do this. And Lorato, I do see your hand, I'm going to get to you now. Just going to do this for you guys to take a screenshot so long, and then we'll continue onwards. Leila, I'll show the mark allocation now in a second. Lorato?
Ma'am, with the question that we just did, so when we are asked about like the concavity, when it would be concave down, we basically include the point of inflection.
Yeah, because at that point, it's still considered concave down, at least say concave up, concave down at that point, and then changes thereafter.
Okay, thank you, ma'am.
Okay, it is quite confusing. I know it's taking me a second to wrap my brain around it as well, but that point is the point where it still has concavity. Okay, right. So there's a question about mark allocation. So the first one was a 4 marker. Just for those of you that are using synthetic division, I've never seen a memo work with synthetic division. I'm not saying that you will be marked wrong. That's not what I'm saying. I'm just saying that when you do look at the memo, just know that that method is not shown. All right. So in terms of, what are we doing? The coordinates of your turning point, you are getting a mark. You're getting a mark for finding your first derivative and making your first derivative equal to 0. And then you're getting a mark for each of your turning point values. Okay, obviously you do have to substitute back to get y. For B, the x-intercepts, you are getting a mark for the quadratic. So this is why I'm saying we don't really ever show the method, because you can just factorize or you can use synthetic division. As long as you get the correct quadratic, you're good. You get a mark for factorizing that quadratic, so getting all 3 of your brackets, i.e. factorizing the cubic completely. And then you're getting a mark for your answers. It will be 1 mark for both answers. Technically, we actually already had that answer. For this last one, increasing, decreasing, what I want you guys to just take note of is, and I did say this, I think, in the function section, is often these questions where there's inequality involved, even though it says 2 marks, those are all or nothing marks. So what that means is you get 2 marks or you get nothing. It's not a case of, okay, well, you got x greater than -1 and x less than 1. No, it's all or nothing. So your inequality must be 100% correct to get that mark. For the second one, because it's 3 marks, sorry, it's a 3-mark question because you had to find the point of inflection. So you get a mark for getting your point of inflection as 0. However you choose to do that is up to you. And then you're getting 2 marks for your answer. Again, those are all or nothing marks. If you had said x less than 0, sorry for you, that's not correct. So it's all or nothing, especially when it comes to inequality questions. Right, so I'll just do this in case you want to screenshot with the mark allocation as well. Otherwise, the next question is asking you to draw the graph. So if you want to get drawing, that's absolutely fine. We'll have a look at it now. You do have all of the information to draw your graph already. Okay. All right, so like I say, question 4 says draw the graph. Now, I said draw the graph. I forgot what the question actually said. So the question says draw the graph of g of x equals, now remember we were given f of x. Okay, and I'll write f of x there in a second for you, but draw the graph of g of x equals x minus 3 cubed minus 3 times x minus 3 plus 2. Now, before we start panicking about what on earth are they talking about, let's just go back. We were given f of x is equal to x cubed. Look how that relates to that first term. Minus 3x. Look how that relates to that middle term. Plus 2. Same thing. So who can tell me these brackets now of x minus 3? What is that as, oh, English. What is that telling me has happened to the original graph of f of x to now get g of x? What does that bracket indicate to me? Let's see if we remember from functions. Nice, Owami. Very nice. Okay. It's a translation. Remember, we know that if we get an expression of x minus p, this is a shift right. If we get an expression x plus p, that's a shift left. Because this is x minus 3, this is telling me that we've shifted 3 units to the right. Okay, so what I'm going to do here, just to make my life easier, is I'm going to write down everything that I know for f of x. And quite literally, all I'm going to do is take those points and just shift them 3 units right. So f of x, I know that my x-intercepts were at 1, 0, as well as negative 2, 0. I know that my turning points were at 1, 0, as well as negative 1, 4. We've worked all of this out. If you're not too sure where I'm getting this information, this is all stuff we worked out earlier. And we know for f of x, remember, this constant term over here is your y-intercept, or you substitute in 0 for x and you get your y-intercept. So we know our y-intercept for f of x, 0 cubed is 0, minus 3 times 0 is 0, so it's just at positive 2. What I now want to do is I now need to essentially shift everything to the right, because that's what g of x is telling me to do. So if I now take g of x, I'm going to do everything I've just done, but just apply my translation. So the x-intercept, if we had an x-intercept at positive 1, 0, and we shifted 3 units right, where does it now end up? Where will that x-intercept end up once it shifted 3 units to the right? Remember, 1, 0, 3 units to the right. Okay, good. It's now going to be at 4, 0. Just if we're struggling, let's pretend this is our coordinates here at 1, 0. If I move it 3 to the right, 2, 3, 4, it's now at 4, 0. So just imagine it like that on your Cartesian plane as you shift or translate your graph. Okay, we can now get the rest. So negative 2, 3 units to the right will now be at positive 1, 0, because negative 2, negative 1, 0, 1. Your turning point, obviously, we already know is at 4, 0 because it was the same. We then have our next turning point, negative 1, 4. We want to shift that 3 units right. So who can tell me where that's going to be? Negative 1, 4, shift 3 units right. Where does that end up? Okay, careful, guys. A lot of you are changing y as well. I'm not shifting up or down. I'm just shifting to the right. Good. Okay, 2, 4. So just quickly, if we're feeling confused, negative 1, 4. There we go. All I'm doing is I'm going right. 1, 2, 3. I don't know what I wrote down. Am I just losing it? Oh. Help if I plotted things in the right place. Okay. So the turning point would be at negative 1, 4. If we move that 3 units right, 1, 2, 3, it's now at positive 2, 4. So again, just imagine your shift. So Kanye, the y isn't changing because I'm not actually shifting my graph up or down. I'm going to draw a terrible graph here for you, so just give me a second. What I'm doing is I'm taking my cubic function, that beautiful thing. Oh, apparently I'm magic. And all I'm doing is I'm taking it and I'm shifting it to the right. I'm not moving it up or down. So what that means, if I shift it to the right, all of my y values remain the same. It's just the x values that I'm now moving. Only if I moved it up or down would my y values change. Does that make sense? Okay, cool. Right, and then our y-intercept, guys, this one a little trickier because what we need to remember is that, yes, the y-intercept is definitely going to change as I shifted right, but we can no longer just shift 0, 2 to the right because that's no longer a y-intercept. So we would need to calculate this again. So this would be where we now substitute in 0 in place of x. Now remember, it's x minus 3 cubed, so 0 minus 3 cubed, minus 3 times 0 minus 3 plus 2, and we get a new y-intercept at negative 16. And now that we have all of this information about g of x, now we can plot our graph. Now guys, remember, this is not going to be an accurate sketch. Okay, we're going to do our best, and it does say sketch. It doesn't, it says draw, but it's a sketch. Okay, sometimes they do give you a Cartesian plane on which to sketch your graph. That's cool, use it. But it is a sketch, so let's not panic about accuracy too much. So we then have our x-intercepts at 1, 0, as well as, English today, as well as at 4, 0. We have our turning points obviously at 4, 0, but also at 2, 4. So that's terrible. 2, 4. And because we know it's a positive cubic, we know the general shape. My cubic is going to look atrocious. Please just work with me. It would also really help if I plotted my x-intercept in the right position. Positive 1, 0, not negative 1. Okay, so we're going to try that again. Okay. Positive 1, 0, 4, 0, and then my turning point at 2, 4. Okay, now we've got our graph. It's not going to look great, grade 12s. We're just going to roll with it though. So it goes up, turning point, turn, down, turning point, turn, up, cubic function. That was a lot better than I expected it to be. I'm just going to pat myself on the back there. Looks much better than I thought it was going to turn out. Thanks, Lorato. Okay, so guys, plot your points. Remember the shape. I'm just going to take off all the rubbish that I put here. Remember the shape, and then you go from there. Not something super stressful. This was a really nice question, and this is what I think you could expect in sort of a trial situation versus the finals. They probably will just ask you a normal sketch the graph, but this was just a nice question to test the translation as well. Okay, so move all your points 3 units left, and then you can plot your graph. Lorato?
Ma'am, so with these questions, like especially when it asks us to draw like a graph and indicate like the intercepts with the axes and the turning point. So for the functions like your parabola, do we your hyperbola, do we need to show like the axis of symmetry or the asymptotes or both?
Okay, so you have to show the asymptotes, but you do not need to show any lines of symmetry or axes of symmetry. You only need to show lines of symmetry and axes of symmetry if we ask you to do so. So even for your cubic, I haven't put the point of inflection on here. You only put the point of inflection on your cubic graph if they ask you to. So asymptotes you have to show, turning points you have to show, intercepts with your axes you have to show, so x and y intercepts. Lines of symmetry, points of inflection, you only do if we ask you to.
Ma'am, what happens if you like showed them? Because I just showed them to be safe in my paper.
You won't get marked wrong. It's not going to earn you extra marks.
Oh, okay, ma'am. That's
Okay, so
all that matters.
Yeah, so it's fine. It's just, it's not necessary. Okay, so if you do show them, cool, that's okay. But you only show intercepts with axes, asymptotes, turning points. Those are the only things. Generally in the question, it'll say indicate. So you can see in this question here, it tells you exactly what we want you to label, indicating intercepts with the axes and the turning points. So that's the only thing I actually want to see. I don't want to see anything else. Okay, but if you show it, great, it doesn't matter. All right, mark allocation here was your turning points were correct. Your shape, you always get a mark for your shape, so draw your shape correctly. Your x-intercepts and your y-intercept. Those are your 4 marks. All right, question 5 is one that we love to hate. Determine the value or values of k such that g of x equals k always has 3 distinct roots. Can someone tell me what it means for a graph, and specifically a cubic, to have 3 distinct roots? What does that mean? And I'm fully aware of the fact that I'm asking you about a question that many of you don't like. So if you don't have an answer, that's not the end of the world. But what does it mean, if anyone can give me something? Okay, Lorato, I like where you are heading. We're going to get there. Nice level. Okay, so 3 distinct roots means 3 different x-intercepts. All right. So for the purposes of this, and remember it's g of x, so this green graph that we've just drawn, for the purposes of this explanation, I am going to do the following just so we can see what's happening. So I'm just going to highlight this. And then we're going to go from there. Okay. So there's my graph. For me to have 3 distinct roots, do you agree I would definitely, okay, let's start with. At this current moment in time, it only has 2 distinct roots. It's got 2 x-intercepts, one at 1, 0 and one at 4, 0. I want 3. If I move this graph up, what's going to happen is I'm only going to end up with 1 x-intercept. This turning point is now too far away from my x-axis to cut. So I can't move it up. If I start taking this graph and I start moving it down, however, what I start to notice is that all of a sudden I do have 3 x-intercepts. 1, 2, 3. 3 x-intercepts. That's what I want. All right. So I can move this graph down, but what I need to be careful of is I don't move it down too far, because now if I move it down so that this turning point at 2, 4 touches my x-axis, I'm back to a situation of 2 distinct roots. I don't want that, okay? So we need to move it down enough to have 3 roots, but not too far down to then end up back at a situation where I've got 2 roots or 1 root. And so essentially what this means is I need to look at a range of values. So I don't want to, I'm just going to draw these lines in because these are sort of my parameters. I definitely need to move this down so that this 1 x-intercept becomes 2, but I don't want to move too far down so that this x-intercept now sits on my x-axis. Now, if you have a look at the distance here, this is a 4-unit distance. From turning point to turning point, that is a distance of 4 units, just vertically up. So what that means is I need to move, if we look at this side of my inequality, more than 0 units but less than 4 units. This makes sense. I definitely can't not move. So I must go more than nothing, more than 0 units. But I cannot go more than 4 units down, because that would then mean that my turning point at 2, 4 sits on my x-axis or even below, and then I no longer have 3 distinct roots. All right, so guys, I get that these are not questions that we like. I do understand that, but it is just important to understand what it is that the question is actually saying to us. And once we can start to visualize the movement, it actually becomes so much easier. When we're talking about roots, we're talking about x-intercepts. All right, so I'm just going to stop there in case anyone wants to screenshot that. Obviously, if you've got questions, you just ask. And then we're going to have a look at the next one. Leila?
Ma'am, for question 4, would you not get a mark for calculating the y-intercept?
No, you just get a mark for the y-intercept. So there's no mark for substituting in 0, but there is a mark for having the correct y-intercept. Does that make sense? Okay. Yeah, it is a bit stingy. I would tend to agree. But generally speaking, when we ask you to draw a graph, we don't actually give you marks for any of your calculations. We just give you marks for your graph. Like this question, what we often do is we sort of scaffold it. So determine your x-intercepts, turning points, and then draw your graph. So you're getting marks for all those calculations elsewhere. But this question, obviously a little bit different. Unfortunately, no marks for any calculations. Lorato? I know, it's very rude.
Ma'am, with question 5, is it like an all or nothing question? So if, let's say, your 0 was a different number, would you like lose both the marks or just one mark?
Yeah, all or nothing.
Okay.
Yeah. So sometimes these K questions, they're a little bit more lenient. So sometimes they'll give you a mark. For this one, though, in particular, it was an all or nothing question. I know. I know, guys. Listen, I've argued it, but unfortunately, I'm a very little fish. I'm not that important. Vashni?
Hi, ma'am.
Hi.
How did you get the less than 4 part?
Okay, so less than... Hang on, let me just get my... Okay, less than 4. If I moved more than 4 units down, do you agree what's going to happen is that this turning point at 2, 4 is now going to sit below my x-axis?
Yes.
Okay, so what will happen then is then I'll only have one distinct root, which is not what I want. So I can't move more than 4 down because then I'm getting a situation I don't want. But I must move between 0 and 4 because that will give me my 3 roots. But anything more than that, I'm now creating 2 or less roots.
Okay, thank you, ma'am.
Okay, pleasure. Alrighty, guys. So there is... I don't know why the math was hard there. 18 minutes left of this lesson. So what's going to happen is the following. Okay. Is this too small for you? Yes, it's fine. So give me a thumbs up if you're okay with it. Give me a thumbs down if it's too small.
Ma'am, it's too small.
Ma'am, it's
Okay.
too small.
Okay, that's fine. Okay, I will just fix this. All right. Oi. Is that better for everyone? She then deleted everything. Okay, some of you are still saying no. All right. Is that better for everyone? Layla, still no.
Ma'am, it's not better.
Okay, so the solution to the problem is to do the following. Okay, don't worry, I'm going to add question numbers. Right. If you tell me this is not better, then I don't know. Are we fine?
It's fine now.
Okay, right. Okay, so these questions, you've got 15 minutes. I would like you to try A, B, C, D1, and D2. Okay, 4 questions I would like you to try. What I will then do is on Monday, I'll put the answers to these questions at the beginning of our lesson. But I want you to try. I want you to ask me questions in these 15 minutes. Get it right. All right. So sort out the problems that you have now. Ask me the questions as we go along and we pick up some issues. I will help you, but let's give these ones a try. Okay. Put answers in the chat. Put questions in the chat. Talk in amongst. Let's get this right. And in case anyone's wondering, the reason I chose this question in particular is first principles and the derivative rules, relatively small portion of marks. The bulk of your calculus marks is working with the cubic functions. Okay, so if you have a look here, this is 915 marks on cubic functions. It's the bulk of your calculus question, so we need to be comfortable with it. Okay, Nikani, that's fine. What I will do, guys, is I will put the answers to this on Google Classroom. Would that be okay? Perfect. Cool. I just don't want to rush you, but I will put the answers up on Google Classroom for you. Right, guys, just a quick random sort of statement here. This format in which we've given you the graph, this is already factorized, okay? So x times x minus 3 squared, that's already factorized. So you don't need to go ahead and factorize. You don't need to stress about anything there. It's done. Then just quickly remember this is f dash or f prime. So f prime where x equals 1 equals f prime where x equals 3 equals 0. We know that when the first derivative is equal to 0, we have turning points. So this is telling me that I've got a turning point at x equals 1 and at x equals 3. It's then also telling me that where x equals 1 on my graph, y is equal to 4. So you have got a turning point because x equals 1 at one of your turning points at the coordinates 1, 4. 1, 4. Okay. So sometimes we do like to change up the formatting of how we give you these questions. Just have a look carefully at what's been given. Lorato, you can. I'll do my best to get to them, but obviously it'll be after the lesson. So you can, and then I can have a look. Okay, guys, if you are working, if you've got any calculus questions that you have over and above, let me know. But yeah, otherwise just keep going, keep doing it. Yes, Lorato, how was paper one? No, we all, generally, guys, I know this is very random. Generally, you do all write different trial papers. Some schools set their own trial papers. Some schools write common papers. Depends on your school. But generally speaking, obviously, everything's at more or less the same standard. So, yeah. Yo, Toriso, that's early. I'm impressed. Flip. How were they? Tell us. Okay, Lorato, some good feedback there. Need to practice more before finals, but more importantly, the time management. And I think that's probably what June and trial exams teaches you most in terms of managing your time appropriately. Guys, obviously, like for the rest of the year, it's just going to be us getting ready for finals. So I promise you, by the time you get to finals, you're going to have practice and practice and practice over and above what you're doing independently. And what I'm going to do my best to do, I don't know how successful I'm going to be, but I'm going to try my best to try and get as many trial exams as possible from like different provinces, and different schools is quite hard because not many schools like to share their stuff, but I'm going to do my best to try and get at least 3 or 4 different trial exams that we can go through before finals, so that A, some of you have already seen it and it's familiar to you, but also B, you can kind of see what the level is at for 2024 matrics, and go from there. Obviously, if you guys write common papers, or if you have papers that your schools don't mind sharing, you're welcome to pop them on Classroom, but I should be able to find most of them, and if I can't, there's plenty. I mean, the goal is to just do maths until we don't want to do maths anymore, and then we're going to be ready for finals. Okay, question. Leila. All right, question. Could I explain how to get the point of inflection? All right, so point of inflection, there's 2 ways that you can do it. You can decide what you're more comfortable with. I'm just going to put a little blocky here on the side just to block off this. Right, I'm going to be honest, I don't know why. I never actually used the second method, which is midpoint. And I don't know why, because it actually seems quite easy, but it's fine. Right, so let's say we've been given a cubic function like this, and I'm just going to make up an expression. So let's say x cubed plus 3x squared minus 4x plus 5. Okay, let's say this is our cubic function. To find your point of inflection, like I say, you've got 2 options. I'm going to show you both. Option 1 is to use derivatives. So you need to find for your point of inflection the second derivative. So this point over here where your concavity changes, the point of inflection is where your second derivative is equal to 0. Now, if you think of that, your first derivative indicates the gradient of your graph. So for example, here, your first derivative, is greater than 0 because it's an increasing part. At your turning point, we know the first derivative is 0. All along here, first derivative, blah, 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 blah. But the point of inflection is where your second derivative is equal to 0. Like I say, my summary that I'm going to put on Google Classroom, much better. So what that would require us to do is obviously know what the first derivative is. Most of the time, you would have worked it out already. But our first derivative here would be 3x squared plus 6x minus 4. And then we go and get the second derivative. The second derivative is quite literally the derivative of the derivative. So I now use this first derivative expression, and I find the derivative again. So 2 times 3 is 6x plus 6. And what I do is I make that equal to 0. So this is how I do point of inflection. But like I said, I'll show you another way to do it now, and you can decide. So negative 6 is equal to 6x, which means that x is equal to negative 1. So what this is saying is that where x is negative 1, I will find my point of inflection. What that means is once you have whatever x is, to find the actual coordinate, you substitute back into the original. Now, the reason we substitute back into the original is because it's on the graph. So it follows the same rule as what the original cubic function is. So this would be, negative 1 cubed plus 3 times negative 1 squared minus 4 times negative 1 plus 5. So that would be minus 1 plus 3 is 2, plus 4 is 6, plus 5 is 11. And so what you've just worked out is that your point of inflection is at negative 1, 11. So this green coordinate here, negative 1, 11. So that's option 1. Option 2 is if you know your turning points, which you can go and work out using your first derivative equal to 0, etc., etc. Once you know your turning points, literally all you do is you find the middle point of it. So I'm going to make this up because I'm not even sure that's going to factorize. But let's say, for example, this was at negative 3 and this was at positive... positive 7, for example. No, that's also shocking because losing my mind. Oh, sorry, guys. Okay. Negative 2 and 0. Let's say that's where our turning points were. If you find the midpoint between 0 and negative 2, so imagine it on a line. Here's 0, here's negative 2. Smack bang in the middle would be negative 1. That gives you your x-coordinate of your point of inflection. And because you then know what your x-coordinate of your point of inflection is, again, you can just go substitute back into your original and go from there. You could technically also, if you knew what the y-coordinates of your turning points were, you could just find the middle point of those y-coordinates and you could get your point of inflection. So you can essentially use what is midpoint to find your point of inflection, or it is the second derivative equal to 0. Either one, absolutely fine. I'm so sorry. Okay, I hope that makes sense. Just let me know. Okay, I see a few things. Let me just make sure. Right, so just let me know if we're happy with point of inflection. Toriso, paper 2 is always worse, guys. It's one of those. Okay, awesome. Paper 2, it's geometry, it's trig, it's generally the sections that we don't enjoy. But again, we're going to practice until we know our stuff like the back of our hand. We'll chat a little bit more a little bit later and we'll talk together about what you guys want to focus on in terms of revising for finals. Obviously, everyone is going to be different. But if majority of you like, oh, I really need help with trig or really need help with geometry, then we spend more time on that. Okay, so we'll chat a little bit more in a little bit. Let's first get through trials. But paper 2 generally does not go as well. Okay. Kristen. Ooh, okay. Do not get to calculus yet, and then will not be included in our prelim paper. After we come back from the holidays, I will be teaching it then. Do I have any advice? Honestly, Kirsten, go watch the videos from our lessons on calculus. Come back even to this video because calculus, I mean, when you come back after trials, obviously it depends on your school, if you're a 3-term school or 4-term school. When you come back from trials, you've got like 2 weeks and then you're done. And quite frankly, your mindset is already, I'm done. So my advice is try and do as much as you can that you're comfortable with now, even if it's over the holidays, and just maybe watching these videos, because everything that we've done in the videos is a general sense of calculus. You'll be able to understand cubic graphs, derivatives, first principle, etc. So that would be my advice. Calculus is a really important section. So as much as you can do beforehand so that when you get to school, you're already sort of comfortable with the concepts, is just going to go in your favor. Again, obviously, we will revise it again before finals, but as much as you can do now. Okay. Lebo, I see your question. How did you find the x-intercepts for 3b? Okay, so x-intercepts is where y is equal to 0. Now, remember, this is already factorized. So even though it's a bracket squared, what you have is your two factors. So if you wanted to write it out without the bracket squared, it would be x times x minus 3 times x minus 3 equals 0. And so your factors would be x equals 0 or x equals 3. So there are your x-intercepts. because those two brackets are the same, it means you have x-intercepts and a turning point. And if you have a look here, it did say to you that your turning points were at 1 and 3. So there is your turning point of positive 3. All right.